Welcome back. We will have a short lesson on a couple of questions on combination of resistors. So here we have combination of resistors. So let's have a circuit. Here we have a circuit with 5 resistors connected together as this. Here we have 3. Now we connect another resistance across here. Here we have a resistor and one more resistor connected in here. Alright, this is it. It's a typical question, usually you get for exams. So this point, let us mark it as A, let this be B. So let this resistor, let's call it as R1, that is equals to 5 ohm. Call this as R2, that is equals to 10 ohm. Here we have R3, that is equals to 10 ohm, and R4, that's equals to, let's take it as 20 ohm, and this middle one, let us take it as R5, that is equals to 15 ohm. Now we need to find out the effective resistance between the points A and B. Now when we see a circuit like that, it looks pretty complex, but this is in fact a resistance bridge circuit. Because it consists of 5 resistors, you can see that R1 and R2 are connected together to the point A, R3 and R4 are connected together to the point B, and then in between these two pairs of resistors, you have this R5 connected. So it's a very simple circuit. So this circuit can be redrawn like this, just like a resistance bridge circuit. Hope you remember what is a resistance bridge circuit. A resistance bridge circuit actually consists of 5 resistors connected in a specific pattern like this. This is the 4 resistors which forms the rectangle. This is R1, that is 5 ohm. This is R2, that is equals to 10 ohm. This is R3, that is equals to 10 ohm, and this is R4, that is 20 ohm, and we have a diagonal resistance connected here. This is R5, this is R5, that is 15 ohm. Now you can see that the power needs to be connected across these 2 points. This is A and this is B. This is the actual equivalent circuit of the circuit shown above. Now in this case, you can see that R1 upon R2 is 5 upon 10 and R3 upon R4 is 10 upon 20. They are equal. So this is a balanced resistance circuit. So here, since R1 upon R2 is equals to R3 upon R4, this is a balanced resistance bridge. So in case of a balanced resistance bridge, these 2 points will be at the same potential, so you can remove the diagonal resistor. So the equivalent resistor, the equivalent circuit ends up like this. You have R1 here, you have R2 in here, and then you have R3 here and R4 here. So this is 5 ohm, 10 ohm, 10 ohm, and 20 ohm, and here we have the connection. We need to find out because we have removed the diagonal resistor now. Now, how to evaluate the effective resistance of this combination? It's very simple now because 5 and 10 are connected in series, 10 and 20 are connected in series, and those two combinations are connected in parallel. So you can write this 5, the equation is very simple because they are connected in series. You can write 5 plus 10, and this is, so if you want to have another equivalent, because if you are not familiar with these kind of things, this is the further reduction of the circuit, further simplification of the. So if you take the combination of these two resistors together, because they are series, you can write it as 15 ohm, and then we have these two resistors connected in series, so you can add them together, that will be 30 ohm, and they are connected in parallel, 30 ohm. So now you have, of course, these points are, you should not get confused with all these points. So this is A and this is B. So what will be the effective resistance of this combination? Because now we have only 15 ohm and 30 ohms resistors are connected in parallel. So what would be the effective resistance? The equation R1 R2 upon R1 plus R2. So you can write R effective is equals to 15 times 30 divided by 15 plus 30. So you can do, okay, let's make it do. So this is 450 upon 45, that is equals to 10 ohm. So the effective resistance of the combination will be 10 ohm. That was pretty easy. So whenever you come across this circuit, you should realize that this is a resistance circuit. Provided these ratios are the same, then you can easily work it out using this relationship. But sometimes you get something slightly different where you get confused very easily. Look at here. Look at another question. It looks a little bit like this, but it's slightly different. Here also we have 3 resistors like this, and not 5 resistors. And now we connect it across with a conductor like this and a conductor like this. This is also one of the typical circuits you get for the exam, A and B. Now let us call this 5, let's say 10, and let's take it as 20 ohm, right? Now when you have a circuit like that, this has nothing to do with resistance switch. There are only 3 resistors. In fact, this combination, you look at here, take the 5 ohm resistor. Okay, one end of 5 ohm is connected to A, the other end is connected to B. Look at the 10 ohm resistor. One end of the 10 ohm resistor is connected to A, the other end is connected to B. Look at the 20 ohm resistor. One end is connected to A, the other end is connected to B. So all the 3 resistors, one end is connected to A and the other end is connected to B. So what is the combination? All these 3 things are parallel to each other. So the the equivalent circuit in this case is something like this. Okay, here. This is the equivalent circuit. It has nothing to do with the resistance circuit, and this point is A, this point is B. This is 5, this is 5 ohm, obviously 10 ohm, and this is 20 ohm. So the effective resistance you can calculate using the expression 1 upon R effective is equal to 1 upon 5 plus 1 upon 10 plus 1 upon 20. You can take the common denominator as, I will continue here, 20, then at the top you will get here, you will get 4, and here you will get 2, and here you will get 1. 4 plus 2 plus 1, that is 7. 7 upon 20. 7 upon 20. So you need to take the reciprocal to get the effective resistance. So in this case, the effective resistance, where shall I write? Okay, I write it here. Therefore, I can put it like this. Therefore, R effective will be the reciprocal of this quantity, that is 20 upon 7 ohm. So these are the two important questions often you get. We can call it as question number 1 and question number, let's call it as question number 2. Should get familiar with that. Thank you for listening to this short lesson. Meet again.